Over the past 2 days, we've been talking about how data is generated, processed, and visualized. And now we are going to focus on the real changes it makes in our cities. In the following keynotes, you will hear inspiring ideas and sessions and case studies that are going to show that data isn't just for reports, but it can drive policy changes, shape urban environments, and also improve public services. This is where we close the loop of data journey, not with theory, but with real, measurable, and applicable outcomes. Now, I'm pleased to hand over the stage to Ed Parham, Director at Space Syntax London. Ed's work is about understanding how city layouts, streets, and public transport affect the way how people live. His talk will explore not just where things happen in a city, but why they happen, by using data to link urban design with health, climate, and everyday life. Ed, hi. I just have a quick question for you. You work on how the shape of the cities is affecting the way people are interacting in the cities. What is the one thing that surprised you lately?
So, actually, it's probably not recently, it's probably quite a long time ago, but actually the thing I was really surprised by was applying some of these techniques, which seem really advanced, in places which are really lacking resource. So the example was applying it in an unplanned settlement. This morning we heard about unplanned and informal settlements. I've worked for a number of years in slums, and one of the things that was really surprising was that even though there wasn't any data, we could make models of them from satellite information, and we could analyze it and understand how it worked before we got there. And when we got there, we could find the street that was busiest, we could find where the shops were, all of these things just from a really simple model that had been made from satellite data.
Wow, that's very interesting. I'm looking forward to hear about your work and
Thank you.
The things you do. Thank you.
Right. Okay, so I'm just going to put this down. This is the shorter version of the title. I think on the program it says something like why, what, when, and where. Really, the point of using data is that we want to try to get positive outcomes, and there's a whole series of questions that go behind that. Before I get into the presentation, I'm going to quickly explain a bit more about who I am and a bit more about Space Syntax. I know this is a data conference. I'm an architect, but I'm an actual architect. I'm not a software architect or someone who does data architecture, but an old-fashioned architect who happens to use data in cities. I work for a company called Space Syntax. We're based in London. We were a spin-out from University College London about 35 years ago. And I'm going to explain much more about the work we do, the models we make, how we use them, all these sorts of things. The key thing is that we do really 5 types of activity. We apply this approach as a studio to design places. We apply it through consultancy, where we might be working with other designers and planners to test proposals. We do training, we do research, and we develop digital tools. So that is a very quick introduction to Space Syntax. And what I'm really talking about, or going to talk about, is cities and complexity. And a lot of these will be themes or ideas that have come up this morning and yesterday. And my excuse for putting this is, I think it's a really nice image, but really it's a way to be able to talk about, to explain a characteristic of complex systems, which is that you have lots of different elements. Those elements or entities interact with each other, and they produce an emergent outcome or an emergent activity. And in this case, this is starlings in a murmuration, is what it's called. Nobody knows what everybody's doing all together. They follow the one next to them, and they get these amazing patterns that happen through the sky. And you might think, well, how is this relevant to cities? This is just a nice photo of birds outside at sunset, and I'm going to show that. So, one of the reasons that Space Syntax was developed and existed was to try to understand the difference between intent and impact. So this is a drawing of a new town in the UK called Cumbernauld. This is the architect's vision, and you can see they've designed it in a really different way. It's not meant to be like a traditional town or city. It's meant to be a new kind of exciting architecture. There's people walking, there's shops which are there, and this was their idea for that particular town. Now, if you move on to the next one, you can see that this is what it looked like in reality. And so there's a really big difference between what the intention was behind the design and what actually happened. And first of all, you notice that there's nobody in the spaces there. The shops have gone out of business. So there's a big difference between what they wanted to happen and what was actually happening. And so Space Syntax was trying to understand, why do we get these differences? Now, what we're really interested in, and this is almost a kind of a logic model that runs through all of our work. I'm going to use an example which is in the press in the UK fairly often. This is quite an old story now, but it comes out, the same story comes out again and again. In this example, it's about people who have saved up for a long time and they've just moved into a new house, but they're really unhappy because they spend the whole time driving. And when you look at it, this particular place, just the other side of these houses, is the town centre. But because of the way the street network's designed, it makes the distance between the houses and the town centre much, much further. All the streets have been designed really badly. It's really difficult to cross the roads. It's not pleasant to walk. So we can see that there's a relationship between the built environment and the activity that happens on a daily basis. And this activity on a daily basis is the emergent activity in a complex system. So there's more research as well that has come out. Again, this is quite old now, but this is looking at the relationship between how people get to work and the risk of obesity. And what this was finding was that people that took public transport to get to work had a lower risk of obesity than people that took public transport. And so that's just walking to the bus at each end of the journey. It wasn't even considering active transport. We know as well that this doesn't just have an impact on the individual, but it has a wider impact on society. So we can start to see in this sequence, the built environment affects what people can do, what people do on a daily basis affects themselves, and it affects wider society. And what we're really interested in doing is trying to avoid this cycle. And we do that by making models. This particular model is taking the street network, it's taking land use, taking public transport, and it's looking at how everything fits together. And so what we can do is we can start to understand what are the characteristics of the built environment that make it car dependent, or what are the characteristics that make it walkable. And if we understand that, then we can make sure that when we're designing new places, we design places where you don't have to drive everywhere, and you can avoid this negative cycle. So we know, I mentioned health outcomes, and I also talked about thinking about things as complex systems. That's a bit difficult to see on the screen, but this is a systems map that was produced by the UK Government Office for Science, looking at the elements that contribute to obesity. There's a whole set of different factors that are interacting with each other. There are things about individual psychology, there are things around people's income, the diets they eat. And so what this is a way of beginning to think about is that some outcomes are really, really complex, and that even if we design the perfect built environment that makes it really easy to walk everywhere, somebody still might not choose to do that. They might do nothing but play PlayStation and eat Mars bars, and they're not going to be healthy, even if they live in a really walkable environment. Now, what they started to do on this systems map was to categorize these different elements. And you can see some of those different points that I mentioned just now. The really important part of this is that the built environment, the physical activity environment, is a part of this diagram. And if you're a planner or a designer or you're in charge of a city, you can't change people's physiology or the food that they eat, but you can at least control one part of it. You can at least make the city physically walkable. You can work with that part of this bigger diagram. And this becomes really interesting because this is something that behavior change practitioners use. And we found this through working on a number of public health projects. And this is, it's called COM-B, which is a behavior change model. And that stands for capability, opportunity, and motivation. And capability is, are people physically able to do something? Motivation is, are they motivated? And opportunity is it possible for them to actually do it? So this is really helpful to be able to think, if you're designing part of a city or you're working in part of a city, this is the bit that you can start to affect. You can create the opportunity for something to happen. With the models that we've got, you can not just look at how to design somewhere from scratch or how to design somewhere to make it possible. You can also analyze existing places, and you can see where the opportunity is missing. You can explain why it's like that and how to change it. So if we want to work through this sequence, one of the things that we really need is data. And so this is the bit where it gets a bit more technical, but it's not going to be technical about how you integrate things. It's going to be more technical in terms of introducing a framework. So I was mentioning earlier that pedestrian activity or pedestrian movement is an emergent activity. This is London Bridge in the rush hour. This is looking south. London Bridge Station is on the top left corner. If you look really closely, everybody is on this side of the pavement. If you look in the background, the pavement's completely empty on the bridge. So there's a big question, why is this happening? And actually, if you start to look at it and you start to look at the city around it, you can see here's the bridge. We have the station on this side. We have the other side of the bridge is the City of London, which is where there's a huge amount of jobs and lots of employment. And people come from the station, they cross the bridge to get to the city. And this side of the pavement is the one that is the easiest for everybody to follow from the station. Now, what's really interesting is this is an emergent activity, and this is some of the systems that are influencing and affecting that behavior and why particular places are used. This is a photo looking the same direction from I think it's the very early 70s, it might be the late 60s. Now, in the time since the two photos were taken, the bridge has been redesigned, there's less space for traffic, there's cycle lanes, London Bridge Station itself has been redesigned, lots of the buildings in the city have been redesigned, but everybody's still on the same side of the pavement. So what that's starting to show is that not all systems have the same effect, and there are bigger systems that are more influential on what's happening on a daily basis. So how can we start to understand this? So we have the model that I talked through earlier, that the built environment can make something possible or impossible. It's not just the streets and the land uses and the density. In a city, you have services that work as well. So you might have public transport. And those services can overcome some of the constraints of the built environment, but they might introduce their own. It might be that it's expensive, or it might be that it's not convenient, or you have to wait a long time. And these things affect the way that people think about things. That affects the activities and behaviors. That affects the impacts on the individual and then on wider society. So how can we use data to understand this and to change things? So one way of thinking about this is like a really simple science experiment. And you might have a set of variables, you mix them together in an experiment, and you create a result. And the reason that we started to position things in this way is because there's so much data that's now available. There's live data, there's device data, there's like tons and tons of stuff. You can get things on Google Maps, you can see pedestrian counts, traffic counts. And the question is, how do you use all of that if you want to get a positive outcome? So what we find really helpful is to use this framework to be able to talk about the variables which are in your science experiment. So those are the things you can actually change. And to say, what is the result data? So if we start to use that framework, we can talk about the activity data is showing you the result of your experiment. We can talk about the data on the variables or the systems as being slower data, and that data changes very slowly. It's really rare to have a new street in a city, for example. And the next thing that this starts to explain is if you're looking at the result data, that tells you what happens and where it happens and when, but it doesn't tell you why it happens. So it might tell you there's 10,000 people on London Bridge at 9 o'clock in the morning, but it doesn't explain why. To understand why that happens, you need to understand the way the systems fit together, the way that that creates certain hierarchies, and the way that that means that they'll be used in a particular way. So if we go back to this photo here, this is essentially the activity data, so what happens where and when, and you can see that on things like Google. But to understand why it happens, we need to look at the actual systems themselves. And these are important because these are the systems that you can change if you're designing a city or planning a city or working in a city. And for that, we need to use modeling. So the next question is, how do we start to combine all this data? And the beginning of space syntax was that it used the spatial network. It looked at hierarchies within the network, and it related that to patterns of activity. In the last 10-ish years, probably a bit longer, we've started to make bigger models. They're more complicated. They combine more data. And that's happened because technology's improved, more people can code. And it's interesting for technical people, but there's a big question of just because you can make something bigger and more complicated, should you actually do that? And one of the reasons we started to do this was that there are a lot of, I'd say, more traditional measures of the built environment which are not especially helpful, or they're not very precise. So this is an image of density that gets used a lot, which came from the Urban Task Force report in the UK about 25 years ago. This particular diagram was put together to talk about how using density was really a good way of doing things because it was really flexible. You could have the same density and you could arrange it as a block of flats, you could arrange it as a kind of a courtyard block, or you could have terraced streets. And so they're all the same density, but if you actually look at the way they fit together, they would be completely different types of city to use on a daily basis, and they would have a different effect on how many people were moving around. So if you think about this block here, some of these streets would be really quiet. There's one entrance to the building. You probably get fewer people walking on some of these streets than others because they're going to the entrance. Again, there's different things happening in each of them. Probably some of these have got different land uses on the ground floor. And so just using one measure of density is not especially helpful to explain some of these characteristics that we were looking at and what makes somewhere walkable or what makes it car dependent. So the way that we have been kind of dealing with this is, first of all, starting with the street network. I use this photo of Barcelona a lot because it's really nice that often when you're looking at a city, you're thinking about the buildings, the physical things which are there. And the bit which is really influential is the network of spaces that go across everything. And often that's the bit you don't see in the daytime. But if you look at the nighttime photos, they show up really, really clearly. There's lots and lots of work that starts to relate the hierarchies within that network to activities and outcomes that happen over time. So this is a paper from about 25 years ago, maybe more, that talks about the relationships between connectivity, pedestrian movement, and then the effect that has on where land uses can survive. And what we have done in the last 10 to 15 years, something like that, is to start to take that same spatial network as a starting point. But what we've done is to use that as a way to combine other built environment systems. I'm not sure if you can see that very well. It's difficult from here, but there's a set of families of different systems on here. So we have urban form, mobility and infrastructure. We have the street network, land use, density, public realm. And then we have things like public transport, private transport, and infrastructure. And we can take layers of data for each of those systems. We can analyze that system in isolation by itself, and that might explain centrality within a city, or we can look at land use. We can take public transport timetable data, and we can start to see how does that connect places to each other. But the really important thing is not just to look at each system in isolation from the point of the system, but to say, how do all of those things work together from the point of a person? And what this is doing is, this is something called the Walkability Index. And what this does is it takes every building and it starts to say, how many different land uses can you walk to within 15 minutes? What's the distance to the closest? And we can start to explain where is more walkable and why is it like that. I'm going to show you a couple of examples of how we've used this. So one of the really important points is not just to have a way of measuring the properties of systems, but to be able to relate those systems to actual activities. So in 2021, we did a big piece of research. We have the Walkability Index for the whole of the UK. We linked it to census data, and what we made was a mode share model that could predict where people were walking to work across all of the census MSOAs in the country. And there were some factors that were consistent across all of these places. And that was, first of all, age was really influential. So were the household size. So households with children, fewer people walked to work. But the really important point was, again, if you're in charge of a city, you can't really control the age of your residents or how many have children, but you can control the walkability. And the walkability was the third part of this that was really influential. I'm going to speed through these bits because I can see how much time is left, and there's some other bits to get into. But we can use this to explain what characteristics are in place where more people are walking. So this is not about coming up with a theory of why do people walk. It's saying where do people walk and what do those places have in common. We worked on one of the projects a few years ago was the NHS Healthy New Towns, and we worked on a development in Exeter in Devon. We gave our model to Public Health, and the Public Health Department linked it to their health data. And one of the things, this was their correlation matrix, and this was our model on the left. And one of the things that the Public Health Department were able to see was the relationship. They knew that often obesity followed deprivation, but not always. There were outliers. So there were places where there was low deprivation and high obesity, and there was the opposite. What was really interesting for them was when you combine that with the Walkability Index, it could start to explain some of those outliers. So the second thing that we've done as well is to validate these models against how people travel to work across the whole of the UK by all modes, essentially. This has gone into a tool that local authorities can use so that when they're allocating land for housing, they can see how much extra carbon is going to be generated by placing housing in different places. The way that this works is there are, I think, 36 or 33,000 LSOAs across the country, which is the census areas. And what we've done is to categorize them according to how integrated they are at different scales. So we can look at an area and say, is it part of a bigger town? Is it part of a bigger region? And based on that categorization, we can first of all start to analyze the actual transport behavior. So we can see how many people are driving. We can also look at the distances that they're driving. And we can then turn that into a forecast model. So we can then start to develop models that take the characteristics of place and location, as well as some of the other characteristics in the census. We can use that to see if you add 100 houses or 1,000 houses, how many extra journeys by car will it be? What distance will they be? And how does that translate to carbon? And that's a screenshot of the tool that there's a number of local authorities are now using it. So that's really explaining the background, the modeling methodology, this framework of positioning data, and starting to talk about validating the metric, the description of the built environment against the activity that happens and the long-term outcomes. So then, this is just some examples of how we can use that intelligence, or how to use it. Now, first of all, if we can see that there are certain places which are naturally more walkable, you can start to use that when you're thinking about allocating growth. So you can start to concentrate growth in particular places where you don't have to have a car. So you can use it for strategic planning. We can also go into more detail on some of these indices. So if we take the walkability index, we know the walkability index affects how many people walk to work. We can say, if we look at this data in the top right-hand corner, what we're looking at is the walkability value here, and what we're looking at on the x-axis is the length of the urban block. So we can start to be really precise to give design briefing information to designers to say, if you want to make somewhere walkable, all of these red dots up here fall in these areas which have got an urban block length of between 50 and 150 meters. Not only are they smaller urban blocks, but they're in bits of the network that have particular characteristics. What this is showing is, in the bottom left corner, again, all of the places, these red dots, which show that it's highly walkable, this x-axis is counting the number of other connections that each street links into. And the most walkable places, you can get to between 3 and 5 other streets. So it tells you that you need smaller urban blocks and you need really good continuously connected grids. So we can take all of this, we can learn from all of these characteristics, and let's see if this works. We can then use that to, yeah, this is playing. We can take some of these characteristics and we can use it to design places. So this is an example from a master plan competition that we did a few years ago. And this part of the city had been identified to extend the city into. What we did was analyze what was there already. We wanted to make sure that if we grew the city, it didn't take all the activity away from the existing city. So we were looking at the most important streets to connect into. Then we built up a set of constraints that were happening on the site itself, so we could see where to develop and where to try to leave open. Now, the next thing was then to connect the most important places together in the way that people move. So you can see that we start to generate that network of paths, and then we refine it. This is going really quickly. So there's years of research have gone into this, but you can see that there are different layers of the network which are there. So we started to add these kind of smaller blocks which are more rectilinear. We can analyze that street network before it's been built, and we can use that to start to allocate land uses and densities. So the red blocks that were there were on the best connected streets. We know they would have more commercial uses, higher densities. The yellow would be quieter, more residential. It's still mixed use, but it would have fewer commercial uses. You can see some of these urban blocks have larger green areas at the center, which related to those constraints that we had at the beginning. So this was the entry for a competition. That won the competition. We then had to do the real project. When we did the real project, we were given a completely different growth forecast. So in this one, the city was going to increase by 3 times, that you really needed to extend the city. When we came to do the actual master plan, the growth was much, much less. And so it became not how do you grow the city, but it became how do you improve the existing city and how do you intensify the existing city within its footprint. And again, we could use the modeling and the data all the way through that to target particular interventions and to test them. So that was the master plan that went on to win a few awards. And then the last bit that I wanted to mention on here was that not every city is growing. Not every city has the budget, has the growth forecast to do it. And you can use these types of data and this type of analysis in a different way. So we had worked with public health departments, and again, to link it back to this behavior change model, one of the things that you can see in this tool on the right is where we're looking at the opportunity that the built environment provides for people to walk. In the background, we're looking at the census data, which shows where do people actually walk. And you can use this to look for mismatches. So you can start to see the city makes it possible to walk, but nobody's actually doing it. So some of these places where you have green buildings on a red background, now you can use that to then go and start to talk to residents to understand why don't they do it. Is it because there's something that you need to change about, I don't know, it might be street lighting or something like that? Is it because people aren't confident enough to walk? And you can tailor a non-spatial intervention. So you don't have to physically change bits of the city if you link these things together. So the real summary that I wanted to be able to talk about was to say that is to come back to this diagram again and to say, I think the point of using the data is that we want to enable positive outcomes to happen. We want to avoid this thing that's been happening for the last 50 to 100 years, where we've built cities and they haven't worked the way that people have wanted them to work or that they thought they were going to work. The problem with this is that a lot of the outcomes that we're looking at are really complex. And we need to be able to position what we can do within this bigger framework. So we need to not claim too much, not claim that you can solve every problem, but really be able to put it into this bigger jigsaw. We need to be able to have data to explain how these things explain how these different pieces fit together, interact with each other and affect the outcome. And we need to be able to understand how the things that we can actually change affect these outcomes as well. And to do that, we need data, we need models to be able to do that. And so while this looks complex, and it is complex, it sounds a bit negative to say, look, the most we can do is make something possible. You can't guarantee that it will happen. But through using the data and the models, we can make sure that we understand it as well as possible to really see what is it that means that this sequence of events can happen and this outcome becomes possible. That then means we can move away from this kind of trial and error design that we've seen, and we can be much more targeted. We can really make interventions precise in response to their local conditions, but also the wider objectives and what you want to happen. And at that point, I'm going to finish. And there's more information on these links down here. So.